Welcome to this session on the PowerPack for Advanced Steel. We're going to be taking a look at our new cage ladder macro. You'll find it under the stairs and railings palette, under the cage ladder tab, and you'll see the command here. You need to select a base point in the model. To start the ladder, you can then select either a second point in the model or drag your cursor up. Using F8 on the keyboard as well to set your ortho, you can enter any particular value that you require in here. So I'm going to enter that value, and you'll see that the ladder will now appear up the side of the dummy wall that I've created. So we can see that in place here. And if we move to the definition tab, we can see that the height that we've defined is here, that I typed in. The width of the ladder is here. All these can be adjusted. Also, there's parameters to change the bias of the width layout as well, where the measurement's taken. If you want to rotate the ladder, you can enter a rotation figure. If you wish the ladder to be at an incline, it can also be changed within the dialog. If we just change to the cage here, we're going to enable the cage, and we'll see the cage appear to the side of the ladder body itself. And with that, all the parameters become active within here. The radius of the cage, the distance from the runs, etc., the start height. And also, you can enter a figure in here to actually offset the top of the cage downwards if you so need for a particular arrangement. So in that case, I just moved it down slightly. Maybe I missed the run here. Maybe I might change this to be bolted later on, so I know there's going to be a clash in there. If we move to the ladder, we can see that the ladder is set up fully automatically to work out the number of runs here. If you uncheck the boxes in sequence, you can actually influence the number of runs by the first unchecking. The second uncheck, you can actually come in and access the run rise field itself, entering in the desired measurement that you require. So if you want them all spaced equally, but the remainder value to be smaller at the start of the ladder, that can be controlled here. This is also being influenced by what we've called constraints. You have a maximum height for the ladder, which will go into the ladder field itself, and run rise, maximum and minimums. First run height as well is controlled. Also, you can define the section profile here. Changing it here will actually change it under the ladder page within the dialog. And also, you can save this configuration to what we've called a standards library. So this can be set as a default and recalled later on. Similarly here, we can see obviously the cage itself. We have a series of primary controls here. By number, by distance, changing that toggle will affect the fields below. You can enter values as required. And again, we have a series of constraints here to inform the user if obviously the ladder is outside of those values for any reason at all. And again, you can control the section profile sizes here, and all this can be stored as a standard library entry and set as a default, same as with the ladder to be recalled later. If we just move to the ladder itself, the ladder page, you'll see here that we're actually pulling through some of those constraint values and obviously controlling the style position here as well. And depending on what section type you select, you have a series of options in here to either flip it or rotate it. Also, the run itself here is controlled. The sizes come through from the constraint. And an important one here is actually the connection to the ladder itself. So if we just zoom in a little bit there, we can see at the moment it's on penetration. If we change it to cut, the hole will disappear on the outside edge. And obviously the boxes become inactive. So let's just put that back to penetration. We'll see the hole come back in. You have a series of other options here to extend or shorten the run as required and influence the hole clearance. If I move to the welds tab, this is pretty standard for our sort of dialogues. But if you look here, we have a slight change. We have both external and internal. If I adjust it to internal, you'll see that one of the weld features actually disappear from the dialog here. So this option gives you the option to control how you want to place the welds, just on the inside of the ladder or both when you've got a penetration situation and you wish to seal it off. So if we just move to the exit arrangement within the ladder itself, So let's just pan up to the top of the ladder. So at the moment we're on a straight extended, and with this we can see that we've activated the runs additional. So that's these series of runs within here. They're controlled independently from the main ladder body itself. If you wish to deactivate them, you can uncheck that there. Also, if you don't wish an exit, you can uncheck it. I'm just going to change this to displayed loop over type, and we'll see now this arrangement appear within the exit. That leads us to the exit details. This tab is now fully active. Within here, we can come in and we can influence what's going on by changing a series of key measurements within here. I'm just going to move the return exit element over, and also obviously it's slightly too long. I can see that it's clashing with the wall there, so I'm going to reduce it down in its height. Similarly, I can control the joint at this point within the actual ladder. So I'm actually going to sort of now change it to a butt. I can actually move it to be on a top loop as well. So that'll change the cut direction here. We've allowed a little option in here to put a convex feature on the corner if you so wish. Runs additional is obviously disabled. If we just move to this other element here, this is a new feature that we added in. It's called the step off. You activate it here and you'll see a mini little platform appear between the ladder body and obviously the area it's supporting against. Again, you have options in here now available to control its section size, its length, etc., and obviously its alignment. You can make a small adjustment here. For example, typing a figure in here, you'll see that the support body will move upwards. If we now change to step off 2, we can see here that we're actually using this to control the spacings between the step off runs as well, and obviously control their section size. And again, you have similar things for the weld penetration arrangements that we saw in the main ladder itself. Let's just move to ladder supports, and if we enable the ladder supports, we'll see the series of them appear within the main ladder itself. So now you can see those have appeared within the ladder body. Obviously their positioning is controlled here, their alignment inside or outside. Obviously you have options to flip them as well, maximum spacing distances. And if you notice, like for example, you have a localized clash, you can actually click into a cell here and type in a figure and actually move a local position. So I'm just moving that one down 50 millimeters. If we come over here, this is actually controlling the configuration of the support, its basic geometry, its thickness, its depth, etc., the return lengths, and etc. there. Also, you can influence the hole diameter within here. If you don't require a hole in the return leg, a little tip, you can enter 0 in there and the hole will be removed, thus avoiding a double hole feature. But if you just want a hole and you're not worried about providing the fixing details separately, you can type that back in and the hole will reappear. Similarly, you have options to control the fixing of the support to the ladder. I'm doing this with bolts now, and you can see that the bolts will appear, and that actually activates the bolts tab. Here you have options to control and select the size and type of bolt available. The location as well is available, and also you can invert the bolt if you so wish, if you wish to change the head direction, etc. And you have positional control as well. Let's just move back to the cage again. So we're looking at the main cage at the moment. So this is the main cage body. The cage is split into two elements, the main and the exit. We come to the straps, we can see the basis of how this works. We do it by segmentation or total length. Changing that will influence the tree dialog you see and the number of segments available. By total length, we'll consider the whole cage as one element. By default, it's set to by segments, and there's individual control within each segment here. If you look, this changes slight difference here by max distance or by number. For section 1 we have by number, and we've defaulted it to 1 and its position there. It has a start offset value that you can place within that if you so wish. Obviously there's options to weld it, you can see them there, and that's for the strap to the hoop, and obviously the hoop to the style. If you wish to change those, you can come back in here and change these two drop down boxes here. If you change that to bolted, it'll appear and the bolts will appear, and obviously the bolts will appear to the style and the hoop itself. That also activates these two tabs here that work very similarly to how the support element was shown earlier on. If we come to the exit cage, we can actually enable the exit cage, and this will form the element around the exit zone of the ladder, extending the cage element up. Again, you can see the cage body has now appeared, and a lot of this is grayed out because we're actually enabling the cage and we're actually using the main cage settings below. If you wish to activate this and change it and do it differently, you can uncheck this box here. Obviously the hoop height can be controlled independent of the ladder height, so if I type that in there, you'll see that it will drop down. And similarly here, obviously we have different options in here, system line or outer edge. You can change the number of hoops that you require within the exit zone. So I'm just going to put 2 in there, and it's going to place 2 equally spaced hoops within that arrangement. Obviously the exit width is linked to the ladder. So obviously if you change the exit width, the ladder or cage will reconfigure. The strap arrangement, again, same as main, so it's inactive, but if you wish to change it, you can change it to influence how you wish to distribute the straps within there. Bolt cage and bolt ladder is the same as we had for the main cage, and we have the same options here, same as main cage checkbox. Finally, to close out, we obviously have a library entry where you can create your own library entry just by hitting the save button. This is fairly typical to our macros, and you can also set that to be your default library entry, which will pull back that exact configuration, including its height and other parameters. So that concludes the ladder itself, and just a small example here. This is like the final ladder sort of finished, and I added in a couple of joints here to fix obviously the return hoop down to the retaining wall on the edge. So that concludes the cage ladder macro as part of the PowerPack for advanced steel. So we're in advanced steel and we have the PowerPack installed from GRAITEC, and we're just taking a look at the multi-grid level tool and the additions that we've added for this version. So let's just create a simple grid here. I'm just going to change the size of the grid here to make it a little bit bigger to see what's going on. So the addition that you'll see for this version is that we've added in manual labeling. By enabling the checkbox, the panels here become inactive, and the actual content of the label itself, its axis title, is transferred to the axis spacing page under the grid axis column here. And you can click in the cell and add in any combination of text that you require in here. Obviously I'm keeping it fairly simple in this case. The same applies to the y-axis as well. You can come in here, just click in the cell, enter your text and then press enter on your keyboard, and the new text will be confirmed and obviously transferred actually into the label content that's being displayed in the model on the left here. So you can see that applied into the fields there. Similarly, if you want to come in, you can use the sub-axis feature here as well, enabling that, and you can enable the main label content will transfer across into that as well. That applies obviously into both fields. Similarly, if you want to come into levels, you can create levels and obviously transfer the grid up to those levels using the tool. I'm just going to put them on several different layers, and you can see that they've all been enabled and all the label content has followed through into the different levels within the model. And now that we've created those levels and transferred them up in the model and all the manual labeling content as well, you may wish to actually revert that. So in order to do that, you would come back in here and uncheck this field, and it will actually revert the label contents to the original source values. And you'll see now here that you can't actually come in and edit this field. If you do decide to go back in and apply manual labeling again, you will have to re-enter your content as required, as currently it does not store that information. But again, that can be simply done just by editing the text in here and placing in what you require. And you can see here it's being repopulated through, even with the grids activated at the various levels. Welcome to this session on the PowerPack for Advanced Steel, where we're taking a look at our multi-grid level tool and a new feature that we've added within this version. So let's first of all just adjust our grid sizes here to make it slightly bigger. So just entering within the dialog, it's changing within the model itself there. The new element I wish to show you is called sub-axes. This is a new page and new elements that have been added into the dialog for this version. You can enable a sub-axis by checking a box here. You can use the main grid label if required. You can also enter a prefix value in here. So if you wish to do that, you can put, for example, a letter in. And similarly here, you can put a slightly different one in there. So you now see that this content is added into the label here that you see within the dialog. Also, you can resize the main dialog itself to see the other sub-axes here. We can obviously introduce this one on this side, do exactly the same thing. For example, we might want to run a prefix there, and we might want to put a suffix there and put B. We might want to come back into here. So you can change and edit this as you like, just by pressing enter on the keyboard. Similarly, the same option applies within the grid structure here as well, enabling the main grid label, and obviously you can change how you put the text in here, so you can manually add those elements if required. Also, you'll notice that you can control the position of this, so you can adjust this measurement in here. So if we adjust this bigger, we'll see that that grid moves over. We can also adjust the axis length as well. So if we change that in there, we can see that the axis actually changes its length. And obviously the same is available under these elements here, and obviously within the y-axis. Also, the sub-axis elements work within the levels feature here of the PowerPack. So you can come in, activate those. You can obviously interact and change the grid level colors if you require. And you'll notice here that there is also an option to disable the sub-axis within a particular grid level via this checkbox here. And obviously if you decide you want it back on, just recheck it and it will reappear. So that's the sub-axis available as part of the PowerPack for Advanced Steel. Welcome to this session on the PowerPack for Advanced Steel, and we're going to be taking a look at our camera browser tool and some new features that we've added within this version. First of all, let's just take a look at a standard camera. A standard camera is used to create drawings from the model, and within this there's a tab for selected objects. Enable this element here by checking this here, and you will see that you'll be able to select a series of objects. So within that you can come in and say select a couple of columns. Just initially we might just select a grid. We can now see that those objects have been added under the selection here. Also, you can use predefined queries that are stored in the model. You can mark the selection, and this will apply a highlighting into the model space itself. You can clear the marking from the model, and obviously you can reset everything as well if you want to. So for the camera browser in this version here, we go and look for the camera that we had used there to create that. That's this particular camera here. If we scroll across in the dialog towards the end of the table now, you will see elements here available. So each one of those elements you saw under the camera are available here. So you may wish to come in and add some additional objects here. So we can select the beams and columns as we wish. So I'm just going to select these series in here. And then I'm going to mark everything just to check that it's been added to it. So we can see there that we've added in those elements. To actually apply the changes directly back into the camera, make sure that you hit the apply button. Obviously you can clear the marking from the particular camera that you want as well. So we clear the marking there. You can use this to reset the selection and clear everything as well. Also the dialog, you can actually stretch the dialog as well if you wish. So let's just return to the camera to just check that everything, as we said, has been applied back into there. So again, marking the selection, we can see all the elements have been applied using the query and the group of objects that we selected. Welcome to this session on the PowerPack for Advanced Steel, and we're going to be taking a look at our new lap joint feature available in this version. Selecting the command, we can zoom in to the area of the model where we wish to apply the lap joint, in this case a railing splice position. We can see now that the joint has been applied to the two railing elements. The first tab we come to is plate definition, and under there we can control the thickness of the splice, and we can see it change as we enter in the dialog. The width of the splice is controlled here, either a relative to the beam or an absolute value. When it's set to the default condition as relative, if you enter a figure in here, it will actually reduce the width there. If you change to absolute, this field becomes active in here and you can change that value. We just pop back to relative to the field, we can obviously see it retained that value that we put in before. Similarly here you can control the length. By typing in a length value, you'll see this increase. Also, you can decide whether you wish it on both sides, one side or the other side. So if we move it to the other side, it moves it to the top. If we apply it on both sides, it will put the lap plates on both sides. So the joint, although designed for railings, can be used in other splice conditions that require that type of assembly. The next way is an offset. This is a bias position, which actually biases the plate slightly relative to the central point. If we put that back to 10, we can see it move back to its original location. If we now move to the connection definition, we'll see that the different sides of the plate have different connectors on them. So side 1 is set to welded under the combo box here. So you have options for welded and bolted. Under welds, you have the typical options here for weld size, weld type, and most importantly, the weld location, which is defaulted to shop. If we toggle to side 2, we can see this is where the bolted option is currently set. And within that, you can access the various parameters that are associated with the bolt type that's stored within the database. This particular bolt is a setless arrangement and has had no nut and washer associated with it. Typically, the bolt can be reversed, toggling here. So if you toggle that now, the countersunk head is actually in the lap plate itself. So just putting that back to the default condition. The other element here is obviously the positioning tab, and we can see here the number of bolts can be controlled here by entering field values here. You can control the distance between the bolts by adjusting the figures in there, and that will close them up about a central location. You can offset the central location if you so wish, moving the bolts one side or the other by entering various figures within these two fields at the bottom. The final location is obviously the library. You can save your library entry by entering the name here, and then once it is stored in the library, it can be set as your default condition for the next time that you use the joint. The tool works with the copy tools of Advanced Steel, selecting the various elements that you need to apply the splice to. It works with the multiple condition as well, so we can come in and we can select those elements as we require. So here we're going to select this position down here, this position here, these two positions up here, and then we're going to select the secondary elements following the prompts for the joint. We can now see that the joints have been applied to those multiple locations within the railing assembly. That concludes the lap joint macro for PowerPack for Advanced Steel.